Hello, welcome. Let's try to solve another Leetcode problem 1209. Remove all adjacent duplicates in string 2. So for this problem, we are given a string, and we can remove the duplicate characters, but they must be adjacent. So for example, if k equal to 2, we want to remove the duplicate character. Duplicate adjacent character. So for example, there's no duplicate adjacent character, so we just return the final string ABCD. And for the second example, we can find something. There are 3, so we can just remove them. And after that, we're gonna have like D and D. Yeah, and we have 2B, but we can remove those 3C. And then we're gonna have B, D, A, A. So there are 3 B's, we can remove them, and there are 3 D's, we can also remove them. So finally, we're going to have the character A and A. Yeah, as you can see, the remove process, it seems this problem we can solve it by the stack. Yeah, so the stack idea, because all the characters are connected, so they are neighbors with each other, they are adjacent with each other, so that means we can use a stack to remove it. Yeah, so the idea is that, in this string, let's use the second example, maybe it's a better example. We're going to put it inside of the stack. So for example, this is D, and we also need to record how many of them. Currently there's 1 D, and then we're going to put E inside, so there is 1 E, and then we put another E inside, so there are 2 E. Yeah. Now we put another E inside, it's going to be 3 E. Yeah. So from here we can check. So if the number of E gonna equal to 3, so for example this is 3, yeah, this is equal to K, so we just need to remove them. So we're gonna remove all of them. Yeah. After remove them, we're gonna continue. Yeah. So E is finished, so we're gonna put a D. So if we put a D inside, we need to record the number, how many of them. So currently the previous D equal to this D, it means we're going to accumulate. Before it is 1D, so D is going to be updated to 2. Yeah. Now we're going to continue, and we're going to put B inside, B with 1B, and another B inside with 2B. Yeah. So we're going to continue. And similarly for C, so C1, C2, and C3. Yeah. As we can see, there are 3 C's, so we're going to remove them directly. Now we're going to remove the C. Yeah, so after remove all those C's, we're going to continue with B. So here, B with the 3, because B equal to 2. Here, the previous one, there are 2 B's, and now B going to be accumulated to 3. Yeah, so if B accumulated to K, K equal to 3, so we're going to remove them. So we're going to remove those B's. And then we're going to continue. Yeah. So after those B's, we're going to continue with D. The previous is 2, so D is going to be equal to 3. So if D equal to 3, we just need to remove those 3 D's. So the stack is going to be empty at the moment. Yeah. Now we just need to put A inside with 1A, another A inside 2A. Yeah. So this is going to be the final array. Now we just need to connect them together. So it's going to be like a string A and A. So this is going to be the final result. Yeah, as you can see, the stack idea is really easy to solve such kind of problem. Yeah. So we're going to prepare an empty stack, and I want to prepare a counter. So I'm going to be count, and then I'm going to check all the characters inside the string. So I want to check if there's something inside the stack. So if stack -1 on top of the stack, -1 with 0, I'm gonna check this character if it's equal to C. So I will update my counter. So my counter is gonna be the stack -1 with 1 plus 1. So otherwise, if it's not equal, so my code is gonna be equal to 1. So if the stack is empty, so my code is gonna just be equal to 1. And after that, I want to put something inside my stack. So the stack gonna append a tuple with the count with the character and the count. So the character is going to be say, and the count is going to be the count. Yeah. Now, if everything's okay, I just put it inside. But yeah, let me just print it out. What is the stack? Let's just have a tag. Let me just return an empty string. Yeah. So for this kind of operation, there's no pop out of the stack. We put everything inside the stack. Yeah. Let's just run it and have a tag. So as we can see, this is our stack A1, B1, C1, and D1. And for the second example, as we can see, B1, E1, E2, and E3. So this is exactly what we need. So if this value equal to 3, equal to k, definitely we need to pop them out. And we're going to continue to stack like that. Yeah. So from here, we want to have a tag. So if yeah, we can directly use the count, because this count is the same value as the stack minus 1, 0. Yeah. So if count equal to k, we just need to pop them out. So for I in range k, and we're going to use the stack dot pop. Yeah. Now let's just tag what is inside of the stack. Let's check the second example. As you can see, this is exactly what we need, and I just simulated what is left behind for the stack. And finally, we just need to join them together. So it's going to be as, well, I think as 0 for s in stack, and we need to join them together. So empty string, join the array. And let me just run it. As you can see, it works for all testing cases. Let me just delete the print and submit it to check if it works. Yeah, as you can see, it works and it's pretty fast because we are using a stack, so the time complexity is OA. That is why we're going to use the stack to solve such kind of problem. Because they are adjacent and they are connected, definitely we can use the stack to solve it. Thank you for watching. See you next time.